So today we are going to focus on the division of radicals and a new concept which is called rationalization, which will make it possible for us to divide our radicals. All right, so again, I just want to review real quick. How do we know when a radical is simplified? There are three characteristics you need to look for. One, the radicand, that's the part that's underneath that radical symbol. The radicand has no factor raised to a power greater than or equal to the index. Okay. Characteristic number two, the radicand does not contain a fraction. Characteristic number three, no radicals are in the denominator of a fraction. So if you don't have any of that going on, then your radical is simplified. So let's look at some examples here. So these examples on the left are not simplified. They don't meet those three criteria. The examples on the right are simplified. And so we are going to learn today how to go from the left, which is not simplified, to the right, which are simplified. So we've been using this division property of radicals for a little while. Okay, it's just made things easier for us. And all that's saying is when you've got a fraction underneath your radical, you can just pull it apart and create two radicals. One in the numerator with that same index, and then in the denominator, same index. All right? Sometimes that makes it easier for us to simplify. But the reverse is also true. Let's say you've got two radicals in the numerator and another one in the denominator. Well, if you smush them or merge them all together underneath that radical sign, sometimes that makes it easier to simplify. So those are two little tools that you've got to use. All right, so we've got some examples here, A and B, which you can look at those examples, okay? But I'm just going to jump right into 1A, okay? By itself, all right, the square root of 160, that's not a perfect square. The square root of 5, that's not a perfect square. Well, what if I merge this whole thing to 160 over 5? Well, that's going to give us the square root of 32, which in itself is not a perfect square. However, it's easy for us to work with. That can be the square root of 16 times the square root of 2. And we know that the square root of 16 is just 4. And so this is going to be 4 square roots of 2. That was not hard. Didn't take a calculator. We were able to just kind of flow with it. Let's look at B. Let's do the same thing. So I'm going to merge it all together, 60 over 3. And when I simplify that, I'm going to get the square root of 20. Again, 20 is not a perfect square, but if I think of what can I multiply to get 20, and are one of those factors a perfect square? Well, sure. I could take square root of 4 times 5, where the square root of 4 is a perfect square. And so this is going to simplify to 2 square roots of 5. All right. Let's go the other way, okay? Where I've got everything underneath the radical, but it's going to be helpful to us to pull it apart, separate it. So let's go ahead and separate this first one into the square root of 5x to the 4th over square root of 20. Well, when I look at this, the square root of 5x to the fourth can be simplified to x squared square root 5. In the denominator, I'm going to have the square root of 4 times the square root. Oops, I'm sorry. Let's just rewrite that a little differently. The square root of 4 times 5. Well, the square root of 4 is 2. So I can think of this as x squared square root of 5 over 2 square root of 5. My square roots of 5 simplify, so I end up with x squared over 2. All right, so let's go ahead and do D. I'm going to do the same thing. Well, actually what I'm going to do before I separate it is I'm going to simplify underneath that radical. I see that 6 and 27 share a common factor of 3. So that's going to be 2 over 9. And then I see that I've got 1x in my numerator, 5 x's in the denominator. So I'm going to get rid of that 1 in the numerator. That leaves me with 4 x's in the denominator. So now I can go ahead and simplify this. So that's going to be, I've got the square root of 2 in the numerator and the square root of 9 over x to the fourth in the denominator. Square root of 2, I can't do anything about that. That's just the square root of 2. But the square root of 9 is 3. X to the fourth, the square root of that is going to be x squared. There we go. That's my simplified radical. All right, let's go ahead and look at E. So the thing about E is, first of all, this 2 is outside of the radical. Second thing is my index is a 3. It's not a 2 anymore. All right, no problem. I also see that I have a multiple, my exponents are multiples of 3. That's going to be helpful. So let's go ahead and separate everything into the numerator and the denominator. So I'm going to leave the 2 on the outside, draw my fraction bar. I'm going to take a cube root of 3x to the 6 over a cube root 8y to the 9th. All right, now I'm going to go ahead and simplify this. Let's draw our fraction bar. Actually, I'm going to keep my 2 out front. So x to the 6, I can take the root of that. That's because my exponent is a multiple of 3. So if I just divide that exponent of 3, that's going to give me my root. My root is x squared. So I pull out the x squared, and then I'm just left with root 3. In the denominator, okay, I got a couple things going on. This 8 is the same as, whoopsie, that 8 is the same as 2 cubed. So I can pull out a 2. I can pull out right here this 9 divided by 3. I can pull out an x cubed, and then I'm not left with anything. Nothing's under the radical. All right, now let's simplify. Let's do this carefully. So my 2 is really like in the numerator, and that can be simplified with that 2 in the denominator. I have 2 x's in my numerator. I have 3 in the denominator. So those 3 go away to just 1. So now I'm left with the cube root, oh, I'm sorry. Oh yeah, I forgot to put cubes. The cube root of 3 over plain old x. There we go. All right. I'm looking at my notes here and I made a mistake. That is not an x in my denominator. That would be a y. All right, if those were x's, what I did was correct, but it's not. So we are going to redo this. Let's bring out our 2, leave our fraction bar. We've got the cube root of 3 in the numerator, and we still can pull out that x squared. But in the denominator, we can still pull out a 2, but we've got a y cubed. Oops, 2y cubed in the denominator, not an x. All right, so our 2's reduce, but that's going to give us x squared cube root of 3 over y cubed. There we go. That looks better. All right, let's go over to F. Okay, so for F, how about if we separate our numerator and our denominator? So we've got this fraction bar here. I'm going to put the 3 on the top, the 4 on the bottom. Then I'm also going to take the 4th root of 7, and then I'm going to break that x to the 6 down into x to the 4th x squared, so that my exponent and my index match. That's going to allow me to take out a root. In the denominator, I'm going to have a 4th root of, I'm going to change that 16 to 2 to the 4th. And then I've got y to the 8th. Okay. So now I've got my fraction bar. I've got the 3. So I can pull out an x, and then I'm left with the 4th root of 7x squared. In the denominator, I've got a 4, but I can pull out a 2. So it's 4 times 2. And then if I take that exponent of 8, divide it by that index of 4, I end up with a y squared. So my final answer here is going to be 3x 4th root of 7x squared over 8y squared. There we go. All right. So now that's how we can apply that division property. Let's go one step further here. And let's learn how to rationalize the denominator when we only have one term. So I'm first going to show you the skill that is called rationalizing. Okay? Honestly, our only goal when we're rationalizing our radical is we're trying to create a radical where the exponent and the index match. Okay? We want to have this situation because then the radical symbol goes away. All right. So, for example, if we start with the 4th root of x cubed, but we want to get to just plain old x. All right. So in order to get to plain old x, I need that radicand to be an x to the 4th so that my exponent and my index match. So right here where this question mark is, I'm going to go ahead and that needs to be an x. Because if I multiply, really that's x cubed times x to the 1st, well that's going to give me x to the 4th. So if I've got my exponent and my index matching, well, then I can just pull out my radicand. That's all we're doing. Let's try one. Okay. So all we are doing is rationalizing right now. So our goal is to get rid of the radicals. Remember, okay? So I'm going to write that. Goal is to remove our radical symbol. So the way we do that is we are going to multiply by a radical, so the exponent equals the index. That's all we're doing. So when I look at example A, I see here that I have 2 to the first. Oops, didn't mean that. I have 2 to the first and x squared. And this index here is an implied 2. So what am I missing? I'm missing a 2. I need there to be one more 2 in order for my radical to go away. So what do I need to do? So I've got here 2 to the first x squared, and I'm going to multiply it by 2, by the square root of 2. So that would give us this 2, and that multiplied by that 2 would be 2 squared x squared. So then my exponents match my implied index of 2. And so that means I can go ahead and take the square root of both of those, 2 squared and x squared, to get a 2x. Okay, let's look at B. So my goal for this one, I need 4 x's and I need 4 y's. Okay, I have 2 x's and I have 3 y's. Well, that's easy. I just go ahead and look at the gap. Okay, so right here, what am I going to multiply by? I'm going to multiply by x squared y to the first. Because here's what I've got, 4x squared y cubed. So now when I add 2 plus 2, that's going to give me x to the 4th. When I add 3 plus 1, that's going to give me y to the 4th. And so then I've got the 4th root of x to the 4th, y to the 4th, which is just going to give me xy. Okay? So you're always looking for what's missing. What's missing? How do I get my exponents to equal my index? That's what you multiply by. All right, so this 81, that's not super helpful, but let's go ahead and change it to exponential form. So we got the 5th root. That's going to be 3 to the 4th x squared y. All right, and then I'm going to multiply that by the same index. So I have 4 3s. I need 5. So that means I need 1 more 3. I have 2 x's, but I need 5. So that means I need 3 more. I have 1 y, but I need 5. So that means I need 4 more. Okay. If all of that now comes together, that would give us the 5th root of 3 to the 4 plus 1, because there's my 1, x to the 2 plus 3, and y to the 1 plus 4. Now all of our exponents equal the index. And so this is going to give me my roots of 3xy. Okay. Let's go ahead and try this one. So I've got the seventh root of 32x squared y. That's where I'm starting. But that 32, that's really, I'm going to think of that as 2 to the 5th. Okay. So now I'm going to multiply that by the seventh root of, let's fill in our radicand. We're looking for or asking how many more of each factor do I need? Okay. So I need 2 more of the 2's. So 2 squared. Of the x's, I have 2. I need 5 more for the y's. I have 1. I need 6 more. There we go. That's going to give me 2xy. This was the part I needed to figure out. Okay. Now, let's use that skill, because that is what is going to allow us, when we rationalize the denominator, it's going to allow us to remove the radical sign, so then we'll have a simplified expression. All right? So, for example, this first one, 3 over the square root of xy. We've got a radical in the denominator. That means it's not simplified. But I have here, I have as an exponent a 1 for each of those. And yet my index is a 2. So I need 1 more x, 1 more y. That's what we're doing here. I'm rationalizing the denominator, but if I'm going to multiply the denominator by something, I have to multiply the numerator by exactly the same thing, because it's like I'm multiplying by 1. All right, so now I've got this x squared, y squared as my radicand, and so that just becomes xy in the denominator. And then in my numerator, I've got 3 times the square root of xy. That is beautiful. That's as good as it gets. All right, you can look at this next example. I want to jump in. So let's take the square root of 49 over 20, and let's simplify. So the square root of 49, I'm just going to put these in. The square root of 49, that's 7 squared. And then the square root of 20 is 4 times 5. Okay. So 7, the square root of 7 squared is 7. Square root of 4 is 2, but then I've got this square root of 5. All right. I can't leave this with the square root of 5. So I'm going to rationalize this denominator. I am going to multiply by the square root of 5 over the square root of 5. What happens then is in my numerator, I have 7 square roots of 5. In the denominator, I have 2 times 5. Because the square root of 5 times the square root of 5 is 5. So my final answer is 7 square roots of 5 over 10. Cool. All right, let's look at B. So I've got, let's simplify this. Let's take this to the square root of 6 over the square root of 25, which is 5 squared. Then let's break that x cubed down to x squared x. Okay, so I'm going to go ahead and simplify what I can. I can't do anything with that numerator. But in the denominator, I can take out a 5x. I've still got a square root of x. That square root of x is a little problematic. I need to get rid of that radical sign in the denominator. If I multiplied by a square root of x, then that would be 1 plus 1, which is going to be, this together will be the square root of x squared, which is going to be x. Okay? And in the top, I've got the square root of x. All right, so then this becomes the square root of 6x over 5x squared. Okay? Where did the x squared come from? Oh, that's because this pink one became x, and we already had one there. That's where it came from. All right, let's go ahead and look at C. All right, so, wow, I know that 4 is a perfect square. However, I'm not looking at perfect squares. Right now, I've got cubes. Okay, so 4 is not really helping me much. So let's go ahead here and break this down into the cube root of 4 over the cube root of 9x squared. Well, that 9, actually, I should think of that differently. Let's rewrite this. Write it as the cube root of 3 squared x squared. So I switched the 9 to just simply 3 squared. Why did I do that? Because it makes it a little bit easier when I try rationalizing the denominator. So I see that I have 2 3's. I need 3. I need 3 3's. So I'm going to create a radical that has the same index as my original. I'm going to put a 3 under here because I need one more. So now I've got an x, but I have 2 of them. I need one more. So whatever I do on the bottom, I have to do exactly the same thing on the top. So together, these become the cube root of 3 to the 2 plus 1, 2 plus 1, which is 3, and x to the 2 plus 1, which is still 3. And so that is going to leave me with a denominator that's just plain old 3x. I can take those roots out. All right. In the numerator, I have matching indexes. So I've got the cube root. I've got 3 times 4, which is 12. I can't take the cube root of that. So it's 12x. That one's done. I know that it's super tempting to take the 12 and the 3 and simplify them. But that 12 is not a pure 12. It's a cube root of 12. And so I can't divide 3 into it. If you put into your calculator the cube root of 12, it's not going to be anything close to 3. Okay. All right, let's go ahead and look at D. All right. So I'm focused mostly on my denominator here. And this denominator is 5, the square root. I'm sorry, that's not wrong. That's not right. I said it wrong. The 5th root of m. So I have 1 m. I need 4 more. All right, no problem. Here we go. So let's go ahead, rewrite this. The 5th root of 2n to the 7th over the 5th root of m. So I'm going to multiply by the 5th root of m to the 4th. Then I'm going to be able to take out a root of m. And if I'm doing that on the bottom, I have to do the same thing on the top. Okay, so now I've got on the bottom plain old m, no radical. That's good. That's my goal. And my numerator, I have the 5th root of 2. That n to the 7th, that bothers me. I need, because that exponent is larger than the index, I'm going to change that to n to the 5th n squared. And then I've got this m to the fourth. All right. So because I did that, this 5 and this 5 match. That means an n can come out. So my final answer is going to be n fifth root of 2 n squared m to the fourth. All of that is over m. That's my simplified radical. So it's okay. You've probably observed that I am fine with having radicals in the numerator. That's all right. You just can't have them in the denominator in order for it to be considered simplified. All right, let's go ahead and look at E. So what do I see? I look at this. I've got 7 over the fourth root of 2x cubed. Okay, so I'm going to multiply by the fourth root. Okay, my indexes, you've probably noticed, my indexes are always the same when I do this rationalization. Second thing, I'm going to start with my first factor of 2. I have 1, 2, but I need to have 3 more so that my exponent will match my index. So I'm going to add those 3 right there. Now I've got a factor of an x. I've got 3 of them. I need 4, so I need 1 more. So because that's what I'm multiplying the denominator by, I have to do the numerator by the same thing. Okay. So now I get in the denominator 2x. Okay. That's because together I have the fourth root of 2 and I add 1 plus 3, so 2 to the fourth. Then I've got my factor of x and I add 3 plus 1, which is 4. So that's how when I can now take the root and get a 2x. That's for the denominator. For the numerator, I've got 7 times the fourth root, 2 cubed. I can't do anything with that, so I'm just going to write it as 8x. There we go. That's all. Done. F. Okay? So for F, I have 3x in the numerator, 2 times the cube root of 5. So remember, this is what people always forget. That 5 underneath that radical has an exponent of 1. So I am going to multiply. I can ignore that 2 in the front. I only have to get rid of the radical. So I'll put the cube root, and then it's going to be 5 squared. Then I do the same thing with the numerator. Cube root, 5 squared. All right. So now when I go ahead and multiply across, let's do the bottom. So these 2 cube roots, that'd be the cube root of 5 cubed. So then I can take out a 5, so I've got 2 times 5 in the bottom. In my numerator, I've got 3x times the cube root of 5 squared, which is 25. Only thing I don't like is in the denominator, those factors, 2 times 5. I'm just going to change that to 10. I'm good. I'm done. Okay. So now, that was rationalizing with 1 term. Now we're going to move on and rationalize with 2 terms. So when we rationalize with 2 terms, we do this differently. What we're going to be using is we are going to be using the conjugate. So remember, if I have a plus b, my conjugate is a minus b. And when you multiply two conjugates that have radicals, the radicals go away. So let's look at this example here. So if I've got, let's look at these two denominators, okay? Oops, I highlighted the wrong ones. Okay. So I start with the square root of 5 minus the square root of 3. Okay, square root of 5 minus the square root of 3. And then I've got the conjugate. So I need to redraw my arrow here. So my difference of two squares comes from that, comes from those two conjugates. And this right here is my difference of two squares. All right. And so the square root of 5 squared is going to give me 5. Square root of 3 squared is going to give me 3. No radicals. 5 minus 3 has always been 2. It will always continue to be 2. Okay? All right, let's go ahead and apply this to some other examples here. So for 4a, okay, so I have two terms in my denominator. Both of those terms are radicals, and I need to rationalize that denominator. So let's start with 1 over square root of 3 plus the square root of 6. I'm going to put parentheses around that denominator. We're talking about a single quantity. Now I'm going to multiply by its conjugate, the square root of 3 minus the square root of 6. But just like we were doing before, if I multiply that denominator by something, I have to multiply the numerator by exactly the same thing. Okay, so in the denominator, I'm going to have 3 minus 6. In the numerator, I've just got the square root of 3 minus the square root of 6, because there would be that quantity times this one. Okay. So then my final answer is going to be the square root of 3 minus the square root of 6 over a negative 3. You can keep this negative out underneath in the bottom. You can put it out front like that. Or you could put it in the numerator. If you put it in the numerator, be super careful and make sure to include parentheses. All right, let's look at B. So for B, I've got a radical. So I still want to go ahead and multiply by the conjugate. So let's just rewrite this as 3 over 2 square root of 7x minus 3. I'm going to put parentheses around that. Now I'm going to multiply by its conjugate. So that's going to be 2 square roots of 7x plus 3 over 2 square roots of 7x plus 3. It's the same darn thing. All right, let's go ahead and let's do the bottom first. This is so much easier. So this is going to give us the difference of two squares. So it's 2 square root of 7x squared minus 3 squared. So 2 squared is 4. Square root of 7x squared is 7x. So this would give us 4 times 7x minus 9, or 28x minus 9. The radical is gone. It's not a single number, but that's okay. The radical is gone, and that's what our goal is. For the numerator, I'm just going to go ahead and I'm going to distribute this 3 to both of the terms in that numerator. So that's going to be 6 square roots of 7x plus 9. There we go. We're done. All right, let's look at C. Ooh, I love problem C. As a matter of fact, you will see C on the homework, and I think it shows up again on the quiz. That's how much it's loved. All right, so let's go ahead and rewrite this as 2 minus square root of 7 over 2 plus square root of 7. I am going to multiply by the conjugate. So the conjugate is going to be 2 minus square root of 7. And so then the numerator is the same, 2 minus square root of 7. All right. Well, for the denominator, the bottom, that is going to be the difference of 2 squares. So 2 squared is 4. It would be 4 minus the square root of 7 squared is 7. Or that gives me a negative 3. Okay. And the top, this is the same as a binomial squared, which gives me a perfect square trinomial. Whew, that's a lot of terms or a lot of words being thrown around. So a binomial squared, what does that look like again? That would be a plus b squared. That's a binomial squared. And that, when you multiply it out, gives you a perfect square trinomial. A squared plus 2ab plus b squared. So when I apply that to this numerator, it's going to be, my a is 2. So that's going to be 2 squared, which is 4. Okay. This one is a minus, not a plus like that. So it'll be a minus. Then it's going to be 2 times 2. The first 2 came from my formula. The second 2 came from my term of 2. Times the square root of 7 plus square root of 7 squared is 7. All right, let's simplify this guy. So I've got 4 plus 7, which is 11, minus 4 square roots of 7. And then in the bottom, I have a negative 3. There we go. That one is done. Okay. And I would just leave that negative on the bottom. If you wanted to bring it out here, I would. You could do that. Okay? You could do that. No problem. All right. Let's look at D. So for D, I'm going to go ahead and start with, okay, make it a little bigger here. Get some of that out of our way. So the square root of 3 plus the square root of 2 over, I'm going to put parentheses, 5 minus the square root of 2. Now I'm going to multiply. Here's where it starts to get fun. Okay, I'm going to multiply by the conjugate of the denominator. So 5 plus square root of 2, and I do the same thing with the top. 5 plus the square root of 2. All right, so now in the bottom, got my fraction bar. This is going to give us the difference of 2 squared. So that's going to be 5 squared minus square root of 2 squared, or 25 minus 2. Well, that would be a 23. All right, so now I've got, for the top, I should have put parentheses around. I'm going to go ahead and multiply. So square root of 3 times 5 is going to be 3 square roots of 5. Square root of 3 times square root of 2 is square root of 6. 2 times 5 would be 2. So plus 2 square roots of 5. And then square root of 2 times square root of 2 is 2. Okay. Well, that's not really super exciting. The only thing that I can really add together, the only like radicals, are those 2 that I highlighted. All right. And so that simply, Just I'm looking at my notes. Did I do something wrong here? Let me just double check everything. Square root of 3 times square root of 5. Got it. Square root of 3 times square root of 2. Square root of 6. Square root of 2 times 5. Maybe 2 square roots of 5. Yeah. No, I'm good. And so this is going to end up with a 23 in the bottom. And then that will be 5 square root of 5 plus square root of 6 plus 2. It's lovely. Okay, let's go ahead. Keep going. All right. Oh, I love it when they give us just A's and B's. It's just there to confuse you. Okay, I'm just joking. All right, so I've got the square root of A plus 2 square roots of B over the square root of A minus square root of B. So you should be thinking, I'm going to multiply times the conjugate of the denominator. Okay, so that's going to be square root of A plus square root of B. And then the top, square root of A plus square root of B. Lovely. All right, let's go to that denominator. You should be getting used to this. This is the difference of two squares. So it's going to be A minus B. That's it. That's the bottom. All right, now for the top. Okay, oops, I need to go ahead and distribute. Square root of A times square root of A. That's just A. Then I get this plus the square root of AB. Now I've got plus 2 square roots of AB and plus 2B. Okay, so the only thing I can really simplify are those middle terms. So my final simplification, I'm going to keep the A minus B in the denominator. So that'll be A plus, now I have 3 of these, A square root of AB's plus 2B. There we go. All good. Okay. Last one. All right. So now let's take and let's go ahead and rewrite this. So negative 9 over square root of 3 minus x. I'm going to multiply by its conjugate from the bottom. So that'll be the square root of 3 plus x. And then I do the same thing, square root of 3 plus x on the top. So that is going to give me square root of 3 times square root of 3 is 3. Okay. And then minus x squared. On the top, I've got negative 9 square root of 3 minus 9x. Okay. I really can't simplify that. You could have left it with the 9 out front, but no, we're good. We're good. All right. Let's go ahead and look at this one application, which is an application using these radicals where we have to rationalize. So here we've got the ratio of the width of the Parthenon to its height is called the golden ratio. And the golden ratio was thought to produce the most pleasant looking rectangles in architecture. So the golden ratio is denoted by the Greek letter phi, where phi is equal to 2 over the square root of 5 minus 1. We are being asked to rationalize that denominator. Okay. So we start with phi is equal to 2 over square root of 5 minus 1. So I'm going to multiply by the square root of its conjugate, square root of 5 plus 1. And I have to do the same thing in the numerator. And so then in my denominator, I get 5 minus 1, because right here, if I take the square root of 5 squared minus 1 squared, that's the difference of two squares. And that's where 5 minus 1 comes from, which is 4. In the numerator, I'm going to have, so let's just change that to 4. So in the numerator, I have 2 square roots of 5 plus 2. Now, the one thing we can do here is actually, before I go ahead and distribute, I'm going to go back. I'm going to go back a moment. I've got 2 times the square root of 5 plus 1 over 4. I can reduce this. The 2 goes into 4 twice. And so my final answer would be the square root of 5 plus 1 in the numerator over 2. There we go. All right. We have done a bunch of examples. So rationalizing the denominator, whether you've got one term or two term, you use two different strategies. When you were rationalizing with one term, that's where you started with your original radical, okay, just one of them, and you needed to multiply by another radical with the same index. You needed to create a situation where your exponents all equal your index, and then you can take the root. When you have two terms in the denominators, and at least one of them is a radical, then you multiply by the conjugate. Those are your two different strategies. Now you're all set. You're going to just do fine on your homework.